In this video, we'll be looking at the Pythagoras Theorem and how it applies to the distance formula. Construction workers, architects, engineers, and surveyors are a few of the professionals who use Pythagoras' theorem in their field of work. In this lesson, we'll be investigating how the Pythagoras theorem was derived. We'll use the formula to calculate unknown lengths of the right angle triangle and explore how it applies to finding the distance between 2 points on the coordinate grid. The lesson will be presented in 2 sections, so it is important to make sure that you have selected the notification bell to be notified of all future uploads. Now, let's start by looking at who developed the Pythagoras theorem. The Pythagoras theorem was developed by the Greek philosopher Pythagoras of Samos, who taught students about religion, politics, and made mathematical discoveries. Now, it's very important to note that the Pythagoras theorem can only be used with right angle triangles. Now, let's consider this right angle triangle. The longest side is called the hypotenuse. Now, I've done a whole lesson on the right angle triangle as it relates to trigonometric ratios, and I've explored in that lesson the 4 main parts of the right angle triangle, so you could give that one a watch. But it's important to note that to identify the hypotenuse of any right angle triangle, the hypotenuse is always opposite to the right angle. So I'm just going to put an arrow here. So here's our right angle. The hypotenuse is that side that's opposite, and it is the longest side of the triangle. So what we're going to do is to do a little investigation to see what is this Pythagoras theorem all about and what is the relationship among the sides of this right angle triangle. Beautiful. So, as I said before, very important to note, if a triangle is not right angled, we cannot at all use the Pythagoras theorem. Now, let's consider this right angle triangle with sides 3 centimeters, 4 centimeters, and 5 centimeters. Now, because we've got the numbers 3, 4, and 5, which are in numerical order, we call this a Pythagorean triple. Now, if it is that we should multiply all the sides by 2, which means the scale factor would be 2, 3 times 2 would give us 6, 4 times 2 is 8, and 5 times 2 is 10. Now, 6, 8, and 10 would also have been Pythagorean triple, since they are scale factors of 3, 4, and 5. But what is the relationship among the sides of the triangle? So here is what we're going to do. We're going to draw some squares from all 3 sides of the triangle. So let's go. So I'll color the first one in blue. So the side there is 3 for that square. For the next one in purple, and for the other side is green. Now we know that all the sides of a square are equal. Beautiful. So what we're going to do in our investigation here, we're going to find the area of all 3 squares for the triangles and then test what is the relationship among all 3 areas. Now, we know that to find the area of a square, we need to multiply side times side. So because all the sides are the same, let's just put that in. So if the length is 3, the width is also 3, and so for the other 2 squares as well, since all sides are equal. So I'm going to find the area of all 3 squares. So for the first one, the blue, we need to do 3 times by 3. So I've got that there. So the area of the blue square is 3 centimeters times by 3 centimeters, which will give us 9 centimeters squared. So let's go ahead, find the area of the purple one. So that would be 4 centimeters times by 4 centimeters as well. So 4 times 4 gives us 16, and centimeter times centimeter gives us centimeter squared. So the area of the pink or purple, whatever color you will see when you see this, it is 16 centimeters squared. The area of the green squared, which is the largest square that comes off the hypotenuse, which is the longest side of the triangle, is 5 times 5, which is 25 centimeters squared. Beautiful. Now, I would suggest you pause the video and see, could you find out what is the relationship among the sides? Okay, now let's see if you got it. So, what I'm going to do here, I'm going to show you my observation. So if you check this out, I'm just going to call the blue square A, B for the pink, and C for the green. So I'm going to add the blue plus the pink. So 9 plus 6 gives us 25. Now 9 and 16 are the two shortest sides of the triangle. So the area of the two smallest squares give us the area of the larger square. So guys, guess what? We have just discovered the Pythagoras theorem. So because I've labeled them in terms of letters A, B, and C, let's form that relationship in terms of the letters. So A squared, because A is 3, so 3 squared represents 9, plus B squared, which represents 4 squared, is equal to C squared, which represents 5 squared. So this is the theory behind the Pythagoras theorem. It says that A squared plus B squared is equal to C squared. So I'm just going to qualify that a bit more. A and B are the shorter sides, and C is always the longest side, which is called the hypotenuse. Absolutely brilliant. So I'm going to put that in a formal explanation now. So the Pythagoras theorem states that for every right-angled triangle, the sum of the square of the shortest sides will always be equal to the square of the longest side, which is called the hypotenuse. Very important that we know the mathematical language. The correct word for the longest side is the hypotenuse. Hence, A squared plus B squared will be equal to C squared always. Now, we could also use other letters as well. What if we say E, F, G? Important to note that we must identify the longest side. And the two shorter sides, when we square them and add them together, it will always give us the answer for the square of the longest side. So you and I together have discovered the Pythagoras theorem. Beautiful. So just to qualify that a bit more, I've just repeated that to say A and B are always the shortest sides. Now, how do we calculate the side, an unknown side of a triangle, if we know two sides? Yes, in order for us to find an unknown side of any triangle, which is a right angle triangle, we would need to know at least two sides if we're going to use the Pythagoras theorem. If we don't know two sides of the right angle triangles, we cannot find another side. So, to calculate an unknown side of a right angle triangle, we follow the steps below. Very important here that you copy the steps along. So step 1, we must first of all identify if we're finding the hypotenuse or am I finding a short side. That is very, very important. Second step, we write out the formula. It's always a good idea to write our formula out and then substitute directly into the formula. Now, so that leads us to step 3, which is substituting into our formula and then solve the equation for the unknown value. Awesome. So write these down and then we're going to put it into mathematical context as we explore some questions. Now, our first example, and I've just broken this down since I'm introducing you to this. where I say specifically in this question we're finding the hypotenuse. So we're asked here to calculate the length of x. Give your answer to 2 decimal places. Very important to pay attention here to the degree of accuracy. So a good practice here would be to underline this. 2 decimal places. So step 1 we just explored tells us to check, am I finding the hypotenuse or is it a short side? Now, because of this caption here, you would have already known that we're finding the hypotenuse. So step 2 told us to write the formula out. And the formula, pretty catchy, says a squared plus b squared is equal to c squared. Amazing. Now we know that we are finding the longest side. So let's go ahead and look at some steps. We're going to label our triangle first of all. We know that C is the longest side. So where X is, we know that's C. It really doesn't matter where we put A and B. The 2 short sides, doesn't matter which one we call A and B, but it's really important that we call the longest side C since it's the hypotenuse. I'll just go ahead and label 4 for A, 7 for B, and X for C. Beautiful. Now we are at the part where we need to now do substitute and solve. But I've broken this down in 3 beautiful steps as it relates to what we need to do now that we've written our formula out. So step 1, after we substitute, we're going to need to square. So A is 4. Let's substitute that in. So we're essentially doing 4 squared plus B is equal to 7, so we're doing 7 squared. And that would be equal to x squared. So remember, we're substituting from our diagram into the formula. So step 1 is to square the numbers. So 4 squared, remember, means 4 times 4 gets us to 16 plus 7 squared, 7 times 7 is 49. Absolutely brilliant. So the next thing we need to do, step 2, is to add them together. So I'm just going to use my calculator. So 16 add 49. So 16 add 49, and that's equal to 65. So note here that 65 is equal to x squared. But we were asked to find x, which means we need to do the opposite of squaring, which is the 3rd step. We need to find the square root. Therefore, I need to do square root 65 is equal to x squared. Find the square root of that side as well. So square root, and to 2 decimal places, I just put that square root 65 in my calculator, and that gives me 8.06 centimeters, and that's equal to x. I have now found my answer, and I've also given it accurately to 2 decimal places. Here is the little summary for this question. Once we are finding the longest side and we've written our formula out, we need to square, add, and then find the square root of the answer. Absolutely brilliant. Make sure that you write your example down, and of course you can play the video over to see this again. So now that we've done that, we're going to go on to finding a short side. What would we then do if we added when we were finding the hypotenuse? So here we're told, calculate the length of x and give your answer again to 2 decimal places. So we've got 3 and 7. 7 this time, however, is the hypotenuse. And clearly the caption tells us we're finding a short side. Brilliant. Now we're going to put our labels in. So this time we are finding the short side. We know our hypotenuse. Step 1 in the previous steps that we've written down told us to write the formula down. So let's go. So I've got here a squared plus b squared is equal to c squared. So what we need to do now is to substitute the values from the diagram into the formula. So A on our diagram is x squared. So we're going to do x, so x squared plus B is equal to 3. So that's 3 squared equal to C, which is 7. So that's 7 squared. Absolutely brilliant. Now that we've done that, step 1, we need to now square. Now, because x is a variable, we've got to keep it as it is because that's what we want to find. So x squared plus 3 times 3 here gives us 9, and 7 times 7 gives us 49. Beautiful. So step 2, we now need to subtract. We've got to do the opposite since we're finding the shorter side. Also, you should have also looked at the video on rearranging formula. When that comes out, make sure that you watch that. We've done quite a bit on solving equations in our revision packs and so on. So this would have been quite important to helping you to navigate this. So if you look here, we are adding 9, so we need to subtract 9, and that's where the subtraction comes in. So on this side, 9 take away 9 is 0, so we're just left with x squared, and that's equal to 49 take away 9 is 40. Beautiful. So third step is to do the square root. So the square root of x squared is x. Now we need to do the square root of 40 and leave our answer to 2 decimal places. So time for my calculator. Just going to put square root of 40, and that gives me 6.32 centimeters, correct to 2 decimal places. Absolutely brilliant. So rhythm, square, subtract, square root when we're finding the shorter side. Absolutely fantastic. Now we're going to do 2 other questions and then we are going to summarize. So here we've got a compound shape. We're asked to calculate the length of the side marked P and give your answer to 2 decimal places. Now we can see here our compound shape is made up of 2 triangles. I want to find the side P. Important to note here that the triangle onto which P rests only has one side. This means that I need to first of all use my first triangle. I'm just going to make a quick highlight around that one to give you a focus. So if I can find the hypotenuse, which I'm going to label x here, if I find the hypotenuse there, I would now have the other side on the larger triangle, which I can now use to find P. Beautiful. So we're going to find x first, and then we would now have enough information. So here we go. I've taken away the scaffold. Want you to recall the formula for yourself. So we know a squared plus b squared is equal to c squared. We check. We're finding the hypotenuse. Clear line of thought here is that in this question, I will need to add, because when I'm finding the longest side, I do square, add, square root. So let's substitute. Call this side A, this side B. So 12 squared plus 18 squared will be equal to x squared. So let's do our 12 squared. Now, for a calculator paper, you do not need to go through what's 12 squared. You could just put this all in your calculator. So let's go. So 12 squared, however, is 144 plus 18 squared. 18 times 18. Let's just put that in our calculator quickly. And that gets us to 324, and that's equal to x squared. Adding them together, I'll just add 144 to that, I get 468. So now I just need to do the square root. So square root in both sides, I get x to be equal to, so the square root of, I'm just going to leave my answer to 2 decimal places as the question said. That's 21.63. So now I found that. Last step, I'm just going to use my calculator for that, and then I would have now found the other side. So put that, a very good way to do this, put what you have found on your diagram to visualize this. Final step is to find P. Now we check, is P a long side or is it a short side? So facing the hypotenuse is 29, so P is a short side. I need to subtract. So I'm going to show you on a calculator paper what you could do. So since I know that I'm going to subtract them, I could just go ahead and say P would be equal to the square root of 29 squared, which is my hypotenuse. Take away the side that I've just found, which is 21.63 squared. Put that all in my calculator at once. So let's go. Square root 29 squared minus 21.63 squared, and then just press equal. Gets me straight to my answer. So the answer is 19.32 centimeters to 2 decimal places. Absolutely brilliant. So you just need to break the question apart. 4 compound shapes. Do not be scared at all. As you can see here, quite manageable. Absolutely brilliant. Final question, and then we summarize. So here is a shape. This time we're applying the concept of area, just to show you how the topics link across your curriculum. So a shape is made by joining a right angle triangle to a rectangle. Work out the area of the shape. Importantly, a 5-marker question here, not drawn to scale. That means we cannot measure the length of the missing sides. So we look at our right angle triangle here. I would need to find the area of the triangle. Let's write that down. We're going to need to find the area of the triangle and also the area of the rectangle, and then add them together. If I find the missing side here, let's call it X, which is the hypotenuse, I would have also known the width of the rectangle. So let's go for formula. A squared plus B squared equals C squared. Since I am finding the hypotenuse, I need to add. So 30 squared plus 16 squared is equal to C squared. So I'm just going to put that all into my calculator. So I'm going to write C is equal to 30 squared, we're going to need to do the square root of that, plus 16 squared. Put that all in my calculator. 30 squared, so square root 30 squared plus 16 squared, that's exactly 34. Absolutely brilliant. So X is 34. Now I can just do my final bits. The area of the triangle is the base times the height divided by 2. So the base is 16. Very important to note. This is my base here. 16 times by my height is 30, and then divide by 2. Get my final answer. So let's go. 16 times by 30 divided by 2 is 240 centimeters squared. Now the area of the rectangle is the length multiplied by the width. So the length is 52, so I'm doing 52 multiplied by the distance we just found is 34. So calculator, 52 times by 34, and that's equal to 1768. Beautiful. Now final step is to add them together. So the area is equal to 240 centimeters squared plus 1768 centimeters squared. So I've got my 1768 already in my calculator. I just need to add that to 240, and that gives me 2,800 centimeters squared. 5 marks, and you would appreciate why that question will be all of 5 marks. Now guys, it's now time for our key takeaways. So we talked about the fact that the Pythagoras theorem was developed by the Greek philosopher Pythagoras of Samos. We also talked about the fact that the Pythagoras theorem states that a squared plus b squared is equal to c squared. A and b are the shorter sides of the triangle, and c is the longest side, which we call the hypotenuse. We also spoke about the fact that if we're finding the hypotenuse, we need to add, we need to square, then add, then find the square root of the answer. However, if we're finding the shorter side, we need to square the values, but this time we need to subtract and then find the square root of our answer. Beautiful. Now, always make sure you identify your hypotenuse and your shorter sides and think about which side am I finding and which formula should I use. Also, once you've learned about rearranging formula, then you can rearrange the formula straight away to get the formula for a shorter side and also know the formula for the longest side. Now guys, I'm thanking you so much for getting all the way to this video. And by now I know you must have subscribed, you must have shared, and make sure that you hit the notification bell. Also, remember that we are on TikTok where we do additional questions. I'll take on some more GCSE exam style questions that links to things like ratios and so on as well. Now, until the second part of this lesson is uploaded, thank you so much for watching.